Thomas, you may be muted. Well, I'll just start off then. Hi, folks. The three things that you guys do as data scientists on a daily basis is essentially code it, scale it, prove it. And for data science to reach the same potential that normal systems engineering has in our world, you need to make sure that your data has the same good practices around it that your code does. You need to make sure that your developers get to use the tools that are the most appropriate to address the problems that they're trying to solve. And your organization has to have institutional confidence in both the data, the code, and the practices that are used to create the deliverables that you do as part of your mission. So the things that are preventing people from doing these things in data science today is that your data sets are always changing, not only time series data, but everything else. You can't make decisions from data if you don't know what version was used to produce a set of results. A lot of times you try to solve that problem by constraining the tooling that your data scientists are using to solve their problems, but that's just playing whack-a-mole with the problem. It's not actually solving it. It's constraining it to the point where your data scientists are not going to be productive. And you can't reproduce results if you can't accurately track everything that went into producing them, both the data, the parameters, well, all of the data, the parameters, and the models as well. So you've got to be able to track the provenance back to all the data and all the code that was used to produce things in the system. So the way we approach this problem is as an interleaved set of requirements that allow you to code it, scale it, and prove it. If you manage your data with the same production practices as code, you're version controlling your data, and that's part of what our one-liner is that we're Git for data, and I'll talk about that in a little bit. But if you want to empower your developers with choice, that leads to the choice of containerized data pipelines. You can, on what's becoming the standard operating system for production large-scale deployments, Kubernetes, provide containerized analyses that let your data scientists use the tool sets that they want to use while still providing them the scalability of it. And if you provide data lineage, you can also provide provability for those results. But all these three things are interleaved because you can't produce scalability without providing data versioning that provides the data lineage, because you have to get the right version of the right data at the right time to the right container. And you have to make sure that you're not doing too much processing because that'll inhibit scalability. So you don't want to reprocess data that you've already processed before. And that's where having the kind of infrastructure that we're going to talk about here helps you produce those. This is a case study of one of our customers. I'll just briefly go on this, but what these guys do is they have the genomes of every, pretty much every bacteria that's out there. They're using them in a large data type way under different combinatorics to see how many substances they can produce for crop science. It's a problem that they have to worry about in terms of the lineage of the different genomes they're getting from these bacteria, as well as the information from the biome that they're processing as well, to make sure that they get the results in there. They chose Pachyderm because it fits all these criteria that allow them to effectively scale their operations in a way that still preserves freedom of choice among the tools while producing confidence in the results that they're getting. So we provide reproducibility through data versioning, and we do it through a Git-like set of semantics on your data. The same set of semantics you use to version your code, you use to version your data. You can identify and revert bad changes. We have a head commit in a commit tree. We have commit IDs that you can use to identify the provenance of data, and you can basically use it as like a time machine for your data. Go back, pick a particular frozen set of data sets in the past, and use it to find out which code operated on those data sets to get reproducible results. We work on top of Kubernetes. Any kind of container you can provide, we can run in Pachyderm. We allow you to connect them in a directed acyclic graph of processing pipelines that allows you to scale your operations. And we handle the heavy lifting of getting the right version of the right data at the right time to a completely running instance. And it also allows you to use the same infrastructure, just like you use Git to trigger development, staging, production workflows. You can use Pachyderm to do the same thing for your data, to stage things for different kinds of workflows using the same infrastructure across all your organization. And we provide this workflow management through data pipelines. You can have any language or framework in a pipeline, add your own pipeline step in here, allows you to create an application that works easily across multiple environments and allows you to easily transition data from one stage of an environment to another using containerized analyses that may use completely different mechanisms in between them to work on the data as you need to work on. And our data provenance allows you to, we are freeze drying every set of results in a version controlled database that allows you to say, 3 months ago, how did we get this particular set of results? What set of data, what set of models, what set of parameters, and what set of code went into producing these results? And you can easily pluck them out and thread that needle in your entire history of your data science. And what this would mean for you and your mission is that you can build confidence in the results that you are doing because you have complete data provenance behind them. You have operational efficiency because we are managing the heavy lifting of getting that infrastructure working for you that allows you to have that provenance and operationally work on your data to deliver the confidence in the results. And it's open source. You have this portability. You can run on any place that Kubernetes runs, in the cloud, on-prem. We don't care. We're an application that runs on Kubernetes. All we need on the back end is an object store to store the version data, and you're off to the races. A little bit about the architecture slide. I won't go into this much here. Probably be good to kind of go into the demo here. There's our architecture diagram, just so you have one, so you can reference it. And let's go through with this and kind of give you an idea of how this all works. Before I go on, are there any questions here? Or would you rather do questions at the end?
Yeah, any pressing questions at this point?
I can unmute people because I muted folks. That might have been why your colleague couldn't speak. Okay, guess not.
Cool. All right, carry on. Well, I think there we go.
Did I unmute? Okay.
We've got mute switched over. We're good now.
Okay, sorry.
Okay, well, I'll go on with the demo. You know, feel free to type something in the chat window. I'll try to keep an eye on that. David, if you could, and call out any questions to me during it. I'll do a brief demo, give you an introduction to it, and we can go on to more complex use cases as we in the questions as we go. This is a very, very simple demo. It's designed to kind of show you the basics of how Pachyderm works. It's a kind of a basic map reduce workflow. And we do it with images because people like images because they're pretty. So we have a data repo here. That's what the blue hexagons are. And that's just like kind of a repo in GitHub, but it's for your data. And we have 3 different files in here. We have a picture of the Statue of Liberty, a picture of some AT-ATs, and a picture of a kitten, because you can't do an internet demo without having a cat in it somewhere. This feeds into 2 pipelines. It's one on the left here is the edges pipeline. That's what the green chevron means. And that pipeline is essentially looks like a Docker file. Here we have this Docker file transform here. Looks a lot like it. We're pulling an image out of Docker Hub. We're running a command in it. Let me show you what the code for that looks like. So this is how you define a pipeline in Pachyderm. It's all JSON. By the way, the UI that I'm showing you is part of our enterprise product. We have a nice, easy, friendly UI that's part of the enterprise product. pretty much everything else I'm showing you from the command line and whatnot is all part of the open source product. We have a fairly clean delineation between enterprise and open source. Enterprise are all the things that you might want to do, like deploy it behind a firewall, use private repositories, add SSL to each layer, role-based access controls, authentication, all those kind of enterprisey things are in the enterprise product. The core features that I'm showing you here are all in the open source product, except for that UI. So here's our pipeline. It's named Edges. It has one input called of the PFS type. That's the Pachyderm file system. That's that version data repository that I've been talking about. And its name is images. And the glob is how we select data. We work really well with unstructured, semi-structured, and somewhat structured data. We abstract everything as a file system because that's the easiest thing for a data scientist to consume. You throw data into us as files. The glob is how you select them for parallelization. So this means select every file on the top level of the repository and treat it as a separate datum. That works alongside with your parallelism spec to make it as scalable as you want it to be. So we can take all these individual datums, we'll parcel them out to individual containers. They'll only see the data that they need to see to operate on them. They'll throw it into the output, and then we'll assemble, merge the results, and give you the results there. It's all fairly transparent. And this is how we're going to transform each of those datums. We have a Python executable that's running here, edges.py. We're pulling it we're executing it in this particular Docker image. And we put this version tag in there just to make it clear to you that we can be part of your current continuous integration, continuous deployment processes. We fit in very well with current best practices in CI and CD that allow you to deploy your data to production pipelines. You check in data to GitHub, that will trigger a CI process that will push this JSON file through our APIs down to Pachyderm to deploy the right image at the right time, and then reprocess any data that you need to have reprocessed. And if we take a look at this Python code, this is not in the best style here. We did this mainly for reasons of illustration as opposed to making it the best Python code in the world. But you can see, you just write Python code, throw it in a container. In this case, we're walking through this input repo, PFS/images. It's presented to you in a very simple way. Use the same open, close file commands that you use everywhere else. That's how you consume it. We're handling all the heavy lifting of the versioning behind the stream. When you throw a file into the output repo, this PFS out, we will manage the commit, and you'll see the complete commit tree after your pipeline runs. I'll show you a pipeline running in a moment here. So we're walking through PFS images and running this make edges function on every file that we find in that input repo. This make edges function uses the OpenCV library to do edge detection on the image. And then we're going to put that file into PFS out. Let's see what that looks like here. I'm going to go back to the repo here. We see this input repo. It's getting input from images. I go into edges, and we see that same Statue of Liberty had edge detection run on it. The @ had edge detection run on it, and the kitten had edge detection on it. And that's our map set. We're splitting up our data. We're running it in separate scalable pipelines. We can run as many of them at the same time as many as our Kubernetes cluster will scale to if we want to. And then there's our reduce step. This montage is another pipeline. We can see its particular code here. It's just some image magic code that's assembling the images that it got out of edges and the images that it got out of images into a complete montage where you see them all side by side. And so we have map and reduce. Let's throw some more files in here. I'm going to go back home here. I'm going to select this edges pipeline so you can see what will happen here. I'm going to pop up a terminal window to show you how you can operate on this. So I'm going to throw a particular set of images in here, 2 additional images. This pack control is our essential, it's like our git command. We're going to put a file in the images repo in the master branch. So you have branches and everything else you have with every other kind of version control system. And we're going to take all the URLs to add from this images added to.txt file. The no port forwarding is a little thing because of the way I did the deployment. It's not going to do automatic kube control port forwarding for me because I'm handling that myself. I'm doing a local deploy here. So I'm going to go ahead and throw this out here. You're going to see here, this particular repo, we're going to have a job that's going to come up here. It's going to start, we'll see it appear in the images, in the edges repo here, a new job. Let me go ahead and refresh this. Pardon me, I'm going to do a little cough. And we see that that a new job, this was the original job where I checked in those 3 files that we saw. Here's the new job that ran with 5 of 5 datums. Let's take a look at it. So what happened here, 5 datums were totally inputted, 5 files, because that's how we selected them with our glob. Only 2 of them are processed, because that's the only new data, right? We are doing differential processing here. It's a declarative semantics that allows you to have a very, very scalable solution with provenance behind it. As you add data, we only change the added data. Of course, you can reprocess everything if you want to. We have complete support for imperative semantics. You can do cron type inputs if you want to, but it shows you exactly how it ran and what it ran on which image. And if we go into this image repo, we'll see there are a couple of files that have been added here. We have a Winnie the Pooh file that had edge detection on it, and we have this girl holding a flower. If I go to my images repo, we see where those files got added to the images repo here. And then if I go down to montage, montage would have had another job kicked off as well, and it added file to this one as well. So now we'll have 5 images in the montage as opposed to just 3. And it's fetching this off my local instance, so it'll take a little while. But one of the things that's been added here for scalability's sake is that, you know, you'll see that we've only processed the new data to it. We assume every time you check in new code that the input-output behavior is going to be the same, but you can tell us it'll be different if it needs to. And if we wanted to see the provenance of this data, I can go into this montage repo, look at all the upstream commits, see, oh, let's look at the provenance on the data in this master repo. So I can click on that, that's the head. It's got 4 upstream commits, 1 from edges, 1 from images, both on their master branch. And I can see, oh, these are all the commits that produce this particular set of data. I get commit IDs on them. I can see all the files associated with it. I could go back to montage, even if I wanted to, look at my output commits and look at one that was 1 back. Here's master -1. 4 upstream commits. This image is master. Those are those 3 files we had there. So I can explore this data, see which version was produced with which section of code. I can look and see the provenance of the individual containers that were there as well. Trace them back to a Git repository. Look at the provenance there as well. And of course, I can do all this from the command line as well. That's kind of, you know, Pachyderm from about 20,000 feet. We can go into any more complex use cases if you want to. I can talk a little bit about other things you can do with the tool. Let's kind of open this up for questions now. Kind of gives you the introduction to how we operate. I don't know if we've unmuted everyone here. We might want to unmute, or you can type your question in the chat window and I can answer it there. If you have any questions about, you know, particular ways to deploy, the environments we support, other particular use cases, you can talk to me about what you do with your data, and I can probably talk about how Pachyderm might solve that particular problem.
Yeah, everybody should have the ability to turn their mute off if they'd like to ask questions. But it looks like you have one in the chat. Could you pull from a remote data source?
Yeah, absolutely. If you look at what I did here, let me go back to this command line here. See, those are just URLs that I pulled from to get that data. And I can specify anything there. It kind of works the way, if you're an old timer like me, you remember when you could do proxy remote send and receive on FTP, where you FTP into 2 sites simultaneously and transfer the files between them? You can do that with Pachyderm. That's what this URL is essentially. It is going to the Pachyderm instance and telling it, go to this URL and pull this data down. Anything that's URL specific, or you can pull things directly in from S3, any object store, anything that's, you know, basically URL accessible. And of course, you can use our APIs within your container. You can have a pipeline where it's pulling data from whatever source you want and then injecting it into an output repo, which is then the next stage of your pipeline. So the beginning of your pipeline doesn't have to be a static repository like this. This could be the beginning of your pipeline, and your container in this code can run as a service that goes off and fetches data from wherever you want and injects it. As a matter of fact, a good example of that is something which is coming out in the next release of our product, which is a Kafka consumer, where you can have a pipeline that's running that's consuming events from Kafka and then injecting them into a pipeline or operating them on some way and injecting data into the pipeline. Do we have any other questions?
I guess I'm wondering if you can comment a little bit on how people use this as a pure open source. And I guess maybe if you can comment a little bit more on the distinction between your open source and enterprise editions.
Sure. I mean, I can probably do one better than that. Let me kind of pop up a really brief diagram. So let me make this a little smaller so you can actually see it. There you go. The open source core includes like everything you need to do to do regular data science, right? The enterprise edition includes that dashboard and the GUI-based admin tools that I've talked about. TLS between all the components, if you have to secure the data between them and you're going that way. Advanced job statistics, if you need to tune your particular components, where we do job statistics that you can use to do data science on your performance parameters. Access controls and authentication as well. Deployment behind a firewall, if you're going to be using private Docker repos and private repos for various things and not have Pachyderm communicate with the internet, there are some things we need to do there as well. More debugging tools, and of course our support and solutions and services organization are part of the enterprise offering as well. A lot of people use use just the pure open source product for, you know, academic and other purposes as well, to do data science in the large in Kubernetes environments without having to rely on a lot of the authentication stuff. They basically are, you know, walling off Kubernetes in their own way, or they don't have a need for those kind of functionality.
Cool, that's helpful. Yeah.
Any other questions? Feel free to type them in the chat window or unmute yourself and chat.
I guess I'll go ahead.
What kind of pattern would you use if you wanted to have say 2 people working on different parts of the same pipeline? Would they have to do everything locally, or could you I don't know, is there some pattern where you could have 2 people working on different parts of a pipeline in some way?
It really does depend. That's kind of a development in the large scenario. Sometimes people isolate different parts of the pipeline. It kind of depends on the problem you're trying to solve, right? Typically, in a production system, just like in any kind of production system, you'll have a CI workflow around it where Jenkins or Circle CI or something of that sort would get triggered when somebody checks in code that would build an image and push it to the production pipeline. And that would be great for when you're dealing with something where you don't want to perturb into production, you don't want to give people direct access. People who are working on a different parts of the same development pipeline, you might isolate them and have subsets of the data in them. What some of our customers do is they actually will have automation, or they manually create subsets of their main pipeline with smaller data sets, like 10%, that they use for staging purposes. And then they have smaller data sets than that that are used for development purposes. And they've either automated or somewhat semi-manually check those out into repos that individual developers work on, that are used to gate from development to QA to staging to production, right? Kind of like the same way you would do a CI system for the code part of your analysis. Does that make sense?
Well, yeah, thanks.
But the key thing to get there is that what we're trying to do with this product is elevate your data to be a first-class object alongside your code in your mainstream data analysis. I mean, data scientists have really just gotten to the point where they've realized that, you know, source code control is an important thing, and they've realized a lot of the DevOps type disciplines that go on behind that. Once you elevate your data to be a first-class object alongside your code, you realize that anything that's not code is essentially data in your analysis and should be version control, should be subject to that same discipline. So your data, your models, your parameters should all be controlled so that you can get reproducible results out. So you can actually say, oh, you know, 3 months ago, we hit some kind of local minimum in what's been happening. Why did that happen? Why are we getting different results today than yesterday? And you have all that at your fingertips to be able to reproduce that.
I'm looking to see if anybody else is unmuted here, but I'll keep going with questions. Can you say a little bit more about what's behind the Pachyderm file system in terms of, like, is there flexibility to run it on a local file system or S3 or somebody else's object store implementation? Like, what's
right? We work with any object store, and a lot of people who are doing on-prem just use Minio behind the scenes. And if you're using AWS, you use S3. If you're using Azure, you use the Azure Blob storage. If you're using GCP, you use the Google Cloud storage. Anything that's an object store that's essentially conforms to the S3 API. One of my customers uses EMC's ECS as their object store and an on-premises OpenShift implementation, right? It's just fine for us. We just work with anything. What we implement on top of it is we use the object store the same way that an operating system file system uses a block driver. We use it to store blocks of data. We're a content addressable file system. When you're inputting files to us, we're actually uniquing them and storing them in a content addressable way. We actually have special operators for things like structured data, which is like SQL files, JSON files, CSV files, or any line delimited data, where we break it apart into pieces and then unique each piece. That's our -- split parameter to put file and on our APIs. That allows you to confidently put semi-structured data in like that and assure that we'll have performant results on the back end and do the right versioning for you on the front end.
Interesting. That's helpful. And actually, see if there are other general questions, we can go there. But I was actually curious if you could step back to those the two architecture diagrams that you kind of went quickly over, and
Sure.
maybe spend a little. I mean, we've got time, and I'm certainly curious to learn a bit more about kind of the parts and pieces of this.
Sure. Let me present that. So the Pachyderm engine, that's Pachyderm. It runs in a container. It uses etcd as its administrative database. So when you deploy a Pachyderm cluster, you're deploying Pachyderm and etcd alongside the dashboard as well, which is also its own container in there, and that's a layer there. That implements both the Pachyderm file system, which is that version-controlled file system that sits on top of the object store, and the Pachyderm pipeline system, We believe that you need both of these to get a performant and scalable data science solution, because if you do pipelines without versioning, you don't get reproducibility. If you do versioning without pipelines, you don't get scalability. So we think they're kind of intertwined together. That's the core open source product that you can use. The access controls, advanced statistics, the GUI dashboard, and everything are what kind of rest on top of it. And of course, that sits on top of whatever Kubernetes cluster, either a bare iron cluster or whatever. And the container system, we work with whatever container system is used in your Kubernetes implementation. Doesn't have to be Docker. If you're doing high performance computing, you can use Cytek's high performance computing container system on bare iron. We work with GPU implementations with Kubernetes in there as well. So whatever resource you want to do there, and when you define your pipelines, you can put the Kubernetes parameters in there that give Kubernetes the directives it needs to give your analytical containers the resources they need. The other slide that was here as well is kind of where you see here is that they use Pachyderm repos with their stores. Our object that rests on top of our object store, and you can essentially do whatever kind of analysis you want in those pipelines. You want to use TensorFlow from there, you can. You want to use GPUs in there, you can. It doesn't really matter to us. We're part of those communities as well. People use them within our tool. They even use things like Hadoop clusters within our tool, even though we were kind of developed in response to the awkwardness of using Hadoop to do things like data provenance. People have legacy systems that are built in them, and they call out to it from within a container, get results, and put it in our version file system.
Good. That's helpful. I'm kind of wrapping my head around this a little bit more now. Are there any other questions on the line? All right. Well, rather than go ahead.
I was going to tell people to type it in if you can't chat right now.
All right. Well, I think we can call this unless you've got more to share. This has been really interesting. I personally have a few projects that could make use of the technology, and I know a number of the folks on the phone will be kind of using this as information to go forward with and figuring out what we're doing next. So this was really helpful. I see you've got Pachyderm Confidential. Actually, I'll stop the recording here.
No, that's okay. That was for when I distribute the